Thank everyone for coming to Building Predictable Systems Using Behavioral Security Modeling, Functional Security Requirements by John Benninghoff. John started Transvasive Security to develop behavioral informational systems, security systems, a new philosophy of security that draws on knowledge on how people behave and interact with information. He has spoken at national and regional security conferences and writes regularly for his company's blog at transvasive.com. So everyone give an applause for John.
Thank you. Thank you for the introduction. I am John Benninghoff. Transvasive is my company. Right now it's just me. So, I can have whatever title I want. I did choose security consultant because, I don't want to be pretentious and be the CEO or something like that. Carl Brophy is the other guy who worked with me on this project. He can't be here today. We were kind of a last-minute addition. And judging by the relative number of people, I'm glad you're all here. But it looks like probably not the sexiest topic, not a big draw. But again, thank you everyone for being here. Behavioral information security is what I founded my company on, and this is part of the outcome of that. Now, I have a lot of experience in security. Carl actually has a lot of experience more on kind of the architectural development side. His passion is taking business needs, business drivers, and turning that into technology, and kind of bridging the gap between the business folks and the technology folks. So I'm going to start out with a quote. This is Donald Rumsfeld. And talking about the known knowns and the known unknowns and the unknown unknowns and all of that. So he was, people made fun of him for saying this when he said it. He was talking about it, of course, in terms of the war in Iraq. But I think this statement is actually very meaningful to me, and because of how I think about risk and uncertainty. So when you're thinking about risk, there's really two types of risks that we face in security. There are things that have happened, and we know they might happen, but we don't know when or where they might happen. So, we may get attacked with SQL injection. We don't know when that's going to happen. We don't know, we don't know who's going to do it, so we don't know a lot of the details, but it is a known unknown. And then there's the unknown unknowns, things that we absolutely can't predict. So something happens and it's totally unexpected. So one example of this was back in the day, there was a great paper a number of years ago, Smashing the Stack for Fun and Profit, ALIF 1. I see some people nodding. This was really the first time somebody said, hey, if we do a buffer overflow attack, we can overwrite the stack and we can inject new instructions and basically force the victim computer to run our own code. This was, at the time, really a novel attack, not something anybody really expected. And again, unknown unknown. We can't defend against that with controls, right? So how do we defend against unknown unknowns? For me, part of the answer is quality, right? So if we have better systems, systems that are built properly, systems that behave how we expect them to, we're going to build more resilient systems. If we have business logic flaws, right, the attackers are going to perhaps exploit that. So one of the ways to fix that problem is to build stronger systems, which for me starts with better security requirements. So here's the second quote. I don't care about security. How many people have actually heard this? Yeah, okay, right, yeah, exactly. So this is really interesting because I was tasked. I was heading up a security team. Our company had decided that it was a good idea to buy a whole new back-end system to do all of our business on. This is for a financial services firm, so you can imagine that security might be important. And I was asked, basically we started asking people, so what security do you need on the new system? It's a mainframe system. I don't know if people here, some people are probably old enough to remember CICS. So we have a bunch of CICS transactions, and we needed to know who needed access to what and what access within each transaction they needed. And the first answer we got was, well, you're the security people, you tell us. And we said, well, we don't know because we don't do your jobs. And so I had to go around on the goodwill tour talking to all of the different folks. I went to one of our senior directors, and I said, hi, I'm here to talk about security. She graciously accepted my meeting invitation. And the first thing out of her mouth was, well, the first thing I got to tell you is I don't care about the security stuff. It's just a pain in the ass. People request new IDs. They have to go through all these hoops, and I don't want to deal with it. During our conversation, it came out later, like about 15 minutes later, oh yeah, and by the way, there's this one function that not only should only people on my team have, only people on this one group within my team have to have access to it because it's so sensitive. So in that conversation, she told me two things. Number one, I don't care about security. Why? Because she saw security as protecting our systems from the bad guys on the outside. She didn't care about that. She had no knowledge of how to do that. She expected us in IT, and specifically IT security, to take care of that for her. But what she really did care about was, what are my people allowed to do within the system? Because that has a lot of importance to me and to my business processes. So this was one of the first instigators of this idea. This was the second. Okay, everyone. We've all seen this. This is XP. I refuse to upgrade, although I'm probably going to have to upgrade to Windows 8. I just set up this new folder, and I want to give everyone access to it. Well, what do you mean by everyone? Okay, is that everybody on your team? Everyone in IT? Everyone in the company? Or everyone who's able to access this directory, even if they're anonymous? Well, my guess is that most people, when they say everyone, they don't mean this. But that's, if you know NT, if you know Windows, that's what it means, right? So now, to be fair, that's probably not true. You probably have to be at least an authenticated user. But they say everyone. That does not translate into this. This is a translation problem. The business users speak of the language of social groups, and the security people have redefined these terms. So, working with Carl, I had this concept of behavioral security modeling. And originally the idea was that we actually model systems, and we model them in social terms. But that actually evolved. When we started looking at kind of the current state of the art in application security, we found a gap. Right? So when we talk about security requirements, and that's, I think, and Carl convinced me that's really what I was talking about, security requirements, there's a gap. Traditionally in security, we talk about security architecture. We talk about non-functional requirements. It's very focused on threats, exploits. We have misuse cases or abuse cases, and it's really about dealing with the known unknowns. So it's about security dictating to the developers, these are the things that you need to do to keep the bad guys from messing with your stuff. So, again, I'm expecting, show of hands, how many people have heard this? This is what you have to do. These are your security requirements. They are now given to you, right? Exactly. But there's a gap here, right? So functional requirements. What are the good guys allowed to do in the system? There was really not a lot in the literature talking about that, and that's what we set out to do. This is really reflecting the functional requirements, the actual business-driven needs. These are reflective of the business controls that need to be in place. Before computers, this was done with procedures. Now we need to implement it in the technology. It's about least privilege. We tell a lot of people least privilege, but how many people actually explain to teams what that means and how they actually implement least privilege? Yeah, it's tough. It's tough. I mean, you kind of know it in your head, but there's no methodology for doing it. It's about insider abuse. If you read the Verizon report, the Verizon Data Breach Investigative Report, my favorite source of actual data about actual incidents, if you look at insider attack, they almost always abuse the authority they already have. They almost never hack. They might actually collaborate with an outsider that hacks, but typically it's they already have the access, they're abusing it, and we have to protect against that. So this is about quality. This is expressed in terms of constraints. We'll talk about that. And again, this is really the way to deal with the unknown unknowns. So that's what leads us to behavioral security modeling. And again, it's called modeling because it started out as a modeling process. It's really evolved into a method for capturing and describing and organizing security requirements. So this is the central premise of behavioral security modeling. There's a white paper. We'll have a link to the website at the end. You can go download the white paper. Makes great bedtime reading. But we get into it a little more detail there, and there's even more theory in there that Carl convinced me to keep out of the paper because probably only me and some other identity management people really care about that level of detail. But here's the central premise, that if you have, for robust systems, that the functional requirements for robust and secure information systems have to define all of the human information interactions permitted by the system. So this is obviously an ideal. This is a high bar. This is probably unachievable. But the idea is the closer you can get to this, the stronger the system will be. Is the system exactly what you intend it to be? Does it define thoroughly, in a whitelist fashion, all of the interactions that the system allows? So there's 4 key components to our approach, the behavioral security modeling approach. The first is constraints. Okay? Constraints is basically how we define a functional security requirement. So a security requirement isn't a requirement in and of itself. I mean, we actually do talk about actually building security things like logging users in and changing passwords and things like that. But the bulk of the requirements that business cares about are around authorization, and that's constraints. It's limitations placed on what people can do on functions in the system and on data within the system. So again, it is a little bit of adding security after the fact, but it's also about defining who's allowed to do these functions. So here's the types of constraints. We have social, which is about who you are. Information, it's about what the data is, the data you're working with. Location, this is physical or logical, where you are, of course. Temporal, this is time windows, time limits on transactions, that sort of thing. And input, which is a pretty broad category, which is all about limits. It's all about what data are you putting into the function that you're calling, essentially. In our approach, input validation actually becomes a subset of this, which is interesting. We'll talk more about that. We have a checklist of questions. So I read a really great book written by a surgeon about the aviation industry. Some people are nodding. They know what the book is. What book? It's the Checklist Manifesto. It's Atul Gawande. It's mangling his name, I'm sure, but it's a fantastic book, and it's all about the history of checklists. So we like checklists, so we put together a checklist of questions. We're working on refining that. But basically, here's the questions that you should be asking to try to get at these various types of constraints. We have requirement patterns. So requirement patterns are something that's somewhat new. When I was working with Carl, he suggested this idea. He said, we have these design patterns, but what we're actually seeing is with a lot of business folks, with a lot of business needs, security requirements actually fall into neat sets of patterns as well. So this may be a more useful concept outside of security, but the idea is that requirements fit into patterns. Now these are like design patterns in that they are kind of templates to use, but these aren't like design patterns in terms of actually being a solution or defining an architecture. It's really more about kind of defining what the business process needs are. So this is, and the last thing, and this thing is actually, I think, really important, go path and no-go path. I stole those terms from some really old military computing security papers, probably from like the 1980s, as you can probably guess by the title. The go path and the no-go path. So the go path is the happy path. If you're allowed to do it, here's what happens. The no-go path is here's what happens if you're not allowed. Now, that may not be access denied. And by pulling it back into the requirements, we're actually forcing people to decide. So what happens if you're not authorized? It could be throw up a dialog box, say, sorry, you're done. Go home. You're done working today. Or it could be something more helpful, like what Microsoft does with SharePoint. Microsoft, if you know SharePoint, you've worked with it, if you click on a link you don't have access to, it throws up a really helpful dialog box that says, hey, you don't have access, but if you type your little explanation of why you need access, I'll send that off to the person who can grant you access. You do that, sends an email off, the person gets it, they click on a link, you have access, email comes back to you, you're off and running. Much better approach, much more friendly. It doesn't interrupt your flow as much. It allows you to move forward towards your objective, which was getting access to the document, because the presumption is, if you're doing it, probably have a reason for doing it. And if you don't, the person who's responding to your email should know that and should tell you, I'm sorry, I can't give you access. So go path and no-go path. That's critical. So as, again, a show of hands, how many people include testing for making sure that everything is working the way it is? Only like half the audience? You don't test your stuff? So how many people test and make sure that when I log in and I'm using the wrong password, it doesn't work? Okay, good. A lot of people doing that. How confident are you that you're getting all of those examples of where things you're doing that negative testing? Some confidence. How confident are you if you're Twitter, or excuse me, Dropbox? So what I argue is that by pulling this all the way back to the requirements step, you're actually going to increase your likelihood of getting that into the design, into the construction, and into the testing. So I'm going to actually walk you through an example. Now, I think in the blurb it said that we're going to have some examples from our early use. That unfortunately hasn't really happened yet. I don't do development, so I really haven't had an opportunity to do this. Carl actually was starting to use this, but the project he's working on has been a little bit derailed. But instead of actually walking you through a real-world example, I'll walk you through a hypothetical example. Now, we actually have kind of looked at our paper after the fact. We do have some improvements that we're already working on. I'll talk about that at the end. But this will give you an idea of how this process works. If you want to know all of the details around the process, please read the white paper. Rather than walking you through the white paper, I'm going to actually show you how it works. So what we have here is a typical, or let's say a prototypical brokerage, right? So I worked in the financial services. I worked for a stockbroker for many years. This is kind of how they're set up. We have clients. And there are different sets of clients. Clients belong to a broker. When a broker leaves the firm, the clients go with them. It's a very personal relationship. We have the associate, sales assistant, or whatever it's called this year. This is the person that actually does a lot of work with the client so that the broker can go out and raise more money. They oftentimes will work with more than one broker. They service clients across different brokers. We have the operations team over here. They're the ones that actually do all the really the heavy lifting, the large transactions, wire transfers, that sort of thing. So in this scenario, what we have is we have a brand new financial services firm. They want a web-based books and records system. In reality, they'd almost never do this. They'd use something already there, but we have basically these three job descriptions: broker, associate, and operations. We have 2 offices. And of course, we're living in an alternate universe where the SEC has a different set of rules, mostly just to make sure that anything I say here doesn't. So if anybody out here actually knows financial services well, I just didn't want to get myself in trouble. So you could say, well, that's not right. That's not how it works. This should be pretty close, but it's just kind of based on my own recollection. So social constraints. Okay, social constraints. So sorry, let's go back. So what we're going to do is we're going to kind of walk through the process of talking through gathering those requirements, right? Gathering those functional security requirements, finding out what constraints are being placed on what people can do. So we're building a brand new system from the ground up, start from scratch, and we're going to be asking the questions and then showing you some of the outcomes that we come up with as a result of those questions. So the first set of constraints we'll go through is social constraints. These are probably the easiest to understand. You know, how many people use role-based security? How many people use only role-based security? Yeah, nobody. And how many people who tried to use role-based security only and found that they ended up with like 1 million roles? So exactly. So social constraints are good, but they're only part of the picture. But again, probably easiest to understand. This is who you are. When you're asking about social constraints, the opening question to try to just basically get an idea of where we're at is, okay, who needs access to this particular function? And for each business function within the system, you're going to have to do this, right? Because you won't know. If you get somebody who understands how the business works really well, that's very helpful. You can save some time. As you go through this iterative process, your business partners will start to understand what you're after, and they'll start, you know, kind of bundling these together in the patterns that you've worked out. But this is all about, okay, so who needs access to what? So we have 3 different kind of social groups, or excuse me, 4 different social groups here. We have the brokers. Well, we're going to allow them to do some things. Or it's interesting. So you might get, well, Bob here, he needs access to this. Why? What about Bob makes him important that he needs access to that? Well, he's the associate. Okay, so really what we're talking about is his role as an associate. So social constraints are defined in terms of the social groupings that are relevant to the organization. And normally this is about access to functions. So going through the interview process, we've actually pulled out a couple of patterns. These are both patterns that we have in our white paper. Role-based access. So role-based access requirements, right? So we have a set of requirements where we have, given these roles, you need certain access. Brokers need access to basically all the functions. Associates only need to be able to see clients and update their name and address and collect paperwork from them and that sort of thing. And the operations people need access to some specialized functions that the brokers don't get access to, like wire transfers, for example. So attribute-based access. So role-based isn't enough, right? So you have social groupings, but you also have kind of attributes, things that are associated with you. Something that's usually a bit. It's either on or off, or it could be, you know, how tall you are. So licensing. So one of the interesting things about the brokerage business is that for both the associates and for the brokers, you can either be licensed or non-licensed. And if you're licensed, you get to trade. If you're not licensed, you don't. Now, starting brokers, when they come into the office for the first time, we're going to hire you. It's a broker trainee class. We're going to pay you. You're going to actually work the phones. You're going to cold call like 100 people a day. A lot of fun, let me tell you. And you're going to do that while working on your Series 7, so that when you actually get done, you can actually execute trades. So until you get that Series 7, until we add that to your profile, you don't get to do the trading functions, right? Same thing for associates. You know, the ones that have their licenses, they get paid more. Why? Because they can execute trades. They tend to work for, you know, the bigger producers, the bigger sales guys. So in this case, no-go path. So if I am an associate and I want to trade, we're actually going to, in this case, we've actually talked to the business and we're going to define the no-go path is if you are not authorized to trade and you try it, what we'll do is we'll automatically take that transaction and forward it on to the broker that has that client relationship and say, hey, you know, you can basically take the details of the trade, pass that off to the broker, and the broker will execute it, calling the client if they have any questions. All right? So if you're a new broker and you don't have your Series 7 yet, instead of passing that off to another broker, we'll just pass it to the operations team. They'll execute the trade. Okay. Again, it's more than just access denied. And by having that conversation, you're opening up opening up the possibility to do things more than just stop work. You're actually improving the workflow. Information constraints. Now this is about what the data is. Right? So what is interesting about the data that, that you're restricting access to? Now, there's overlap between these different kinds of requirements. Don't get hung up on that like I did. Carl had to talk me down a couple times. But again, this is really just kind of a series of reminders to help you work through the different possibilities around mainly authorization. So in this case, we have a couple of different templates in use. We've talked to them. We said, all right, so what data does this broker need access to? Well, they need access to the client data. This associate needs access to both the brokers in that office number 1, but not office number 2. And we've got to go through these permutations, and what we end up with, okay, so we have role-based data access. If you work with these clients, you get access to their data. If you don't work with those clients, you don't. Very simple. Now, this is a way of dividing up who gets to access what based on the client relationship. We have dual controls. This is another information-based constraint. So if I'm writing a check, so a client wants a check. They want some of their money out. It's a two-step process in most firms. Somebody has to request it, and then somebody has to approve it. And these are separate functions, has to be different people. It's enforcing a long-standing requirement in the financial world, which is dual controls. So so no one person can just kind of steal money from the account. You have to have 2 people. So that's another information constraint. This is another pattern that we have. And finally, the other one is my data. So clients get access to their data by default. They log into the website. They have a customer portal. It's associated with this system. And clients get access to their data and nothing else. So no-go path. How do we handle the no-go path for clients? If you don't have access to a client, we don't show it to you. That's simple. So no access denied, no weird messages. You just don't see it. It's like those clients don't even exist. Again, security gets out of your way. It's more user-friendly. Doesn't interrupt the flow. How are we doing for time here? Let's see. Well, getting close to the end. All right. All right, location and temporal constraints. We'll kind of whip through these real quickly. Where are you? What time is it? Good timing, right? What time is it? Like time limits on transactions, which Ticketmaster, of course, brought into the world. So we have, again, for this environment, we do those questions. We say, okay, so when can people execute these functions? Where do people have to be to execute these functions? Can they do it by remote access? Right, so what comes out of that conversation is we have a couple of requirement patterns. On-premise only. So the operations people, they actually used to be called cage operators. Why? Because thanks to 1930s era SEC regulations, you actually had to have a physical cage, and I believe you still do, where that's separate from the rest of the office, where the cage people actually sit. It has to have like a door. I mean, it has to be closed off with a door. It doesn't have to be secure anymore, but it does have to be closed off. So again, you have to be there to execute the function. So what we're going to say is, sorry, operations people, no working remote access. That's okay, because they only work during market hours anyway, but you have to be on premise. Now, the other thing we come up with is a temporal constraint. The trading functions are only allowed during market hours. Makes sense. Doesn't make sense to execute a trade when it can't happen. So after hours, you can look at all the clients, you can look at the clients' positions, but you can't actually execute trades. But we're going to define the no-go path, and what we're going to say is if a client comes in and asks for a trade after hours, and you enter it in, it'll say, hey, would you like to execute this trade first thing tomorrow morning when the market opens? Say, yeah, sure, let's go for it. Finally, input constraints. And I'll try to get through this so we have time for questions. Input constraints, now these are about parameters. Right? These are about limits on input to the function that you're working on. Now again, that sounds an awful lot like input validation. Why? Because again, in our model, these are kind of one and the same. We're blurring the lines here between security and quality. but I think that's okay, and that's part of the point. So what we have here, again, with input constraints, we have role-based transaction limits. So depending on what role you have, whether it's a broker, associate, client, or operator, well, clients don't really get that permission. Broker, associate, operations, they have different trading limits. They have different dollar numbers that they're allowed to trade, different stock volumes they're allowed to trade. Typically what you'll see, associates have some. If they're licensed, brokers have more. Depending on how many clients they have, how big of a producer they are, they might get higher limits. Operations people, they have essentially unlimited with some checks and balances. Now, input validation, you should always have that, right? Now, hopefully you can actually include as much of the input validation of the requirements as possible. Because in my conversation with Carl, he pointed out, input validation is a tricky thing because the developers assume one thing is valid and the business people assume something else is valid, and they rarely talk about it. So again, it's important, as much as you can, as much as is reasonable and proper, to talk about that. What are the legitimate inputs to this function, given the business requirements? What makes sense within the business context? And then the no-go path for trading, try to exceed your limits. It'll automatically kick you up to operations who will execute the trade for you. All right. Any questions on this model and this approach? I kind of glossed over it. Like I said, there's a lot more details in the white paper. So what's next? Like I said, I mentioned the white paper several times. It's out there. Right now, it's kind of buried on the website, but I'll be posting these slides on the website and a fresh link to it later today. I think if you scroll down, you'll find it. You have to go to page 2 or 3 right now. Field testing. If you would like to do it, please let us know. And we're working on a question checklist. One is this kind of a summary, full summary of the white paper. The other one is a one-pager that you can actually lay on the table when you're in a requirements session. Patterns website, we hope to put up a wiki to actually collect these patterns and allow people to submit their own. And then extending this later into the life cycle, we may actually get to the modeling part of behavioral security modeling. So, well, I think we're about out of time, so thanks to everyone for coming. If you had other questions for me, feel free to come up where we can talk out in the hall. I have a set of business cards, and thank you for your time.